Hello and welcome to the course Basics of Experimental Design for Cognitive Psychology. I am Dr. Ark Verma from IIT Kanpur. We are in the 5th week of the course and this is going to be the second lecture. We have talked about in the previous lecture about one-way experimental designs, about causality, and we basically saw how does a simple one-way experiment work in both a between participant setup as well as a within participant or a repeated measure setup. Now, let us take it forward and talk about factorial designs. So, let us say typically when you construct a single variable or a simple one way experiment, it is good, it tells you about the causal relationship between the two variables. But if you look at this that in daily life or in everyday settings, it is not, more often than not, it is not just a single variable that is causing a change in a given behavior. Typically what happens is that there is more than one variable that might be affecting the behavior of interest, and in that sense you might want to study the behavior of interest, how that is getting affected by more than one variable. So, in those cases what we need is we need more than one independent variable, the effects of which you want to measure on your dependent variable. So, for example, aggressive behavior, we were talking about this example of watching violent video games or watching violent cartoons. How does it affect aggression? Now, if aggression is the behavior of interest, aggressive behavior can probably be influenced by the amount of violent television that the child has watched. Yes, that was the first variable, but it also could be affected by the disciplinary style of the parent. It could be affected by the child's mood state before they came to the experiment. It could be affected by the socioeconomic status and any number of things. Now, if you are interested in sort of understanding the behavior of interest in more detail, it might be a better idea to take into account a number of variables at the in the experiment, and all at the same time, so that it basically tells you what are the various influences on this behavior of interest. Okay. Another example could be, say for example, there is this ability to memorize new information. It could be influenced by both the type of the material, let us say easy material, difficult material, and you can operationally define easy and difficult, but it also vary on the memory, basically your memory capacity that you have, or other factors, organization of material, for example. So, if there is a behavior of interest that you want to study and you want to understand in more detail, typically it is a good idea to take into account or to basically create an experiment that allows for not one but maybe two or three, not many at the same time, but maybe one or two or three variables at the same time is possible. You can take that, and the factorial design basically allows you that kind of manipulation. So, let's look at this. Experimental designs with more than one independent variable are known as factorial designs. Okay. So, whether it has 2 factors, 3 factors, 4 factors, all of that is referred to as a factorial design experiment. The term factor refers to each of the manipulated independent variables. So, how many factors does a study have? Say for example, if you have experimental design that has 2 independent variables, it will be a 2 factor study. If it has 3 independent variables, it is a 3 factor study. If it has 4 independent variables, it is a 4 factor study, and so on. Now, depending upon the number of factors that these designs have, you can call your design a 2-way design, or 3-way design, or a 4-way design, and so on. Also, factorial designs are described with a notation system that concisely indicates how many factors your experiment has, but also how many levels each factor has. For example, look at this. If you say that you come across a 2 cross 2 design, 2 cross 2 design basically means, because there are 2 numbers which are crossed here, so it means 2 variables, and because the number is 2, it basically says each variable has 2 conditions. So, let us say we were talking about in earlier examples we were talking about laterality, or say let us say in this experiment, let us say we are talking about mood state of the individual and the video game that they have watched. So, the type of video game that they have watched is one factor, it has 2 levels, violent video game, non-violent video game, and the type of mood state, frustrated, not frustrated, happy, not happy, anything like that can be taken. Okay. So, 2 cross 2 basically means 2 factors with 2 levels each, 2 cross 3 basically means 2 factors, one of the factor has 2 levels and the other factor has 3 levels. That is basically how the notation works. Now, the use of more than one independent variable in a single experiment increases the amount of information that can be gained from your experiment, that can be gained from the experimental design. It is also more economical in the sense that basically you will now need lesser number of participants, and you can basically get more information about these variables, their causal role in your dependent variable, and the possible interaction between these variables. How do these variables affect each other in bringing about the change in your dependent variable in the same experiment with fewer participants in hand. Obviously, you have to take more measurements and so on, but we will talk about that going forward. So, this happens because factorial designs provide all of the information that would be gained from two separate one-way design experiments. So, you can study, let us say, mood state in a separate experiment, you can study type of video game watched in a separate experiment, but it gives you that, but it also gives you how the mood state will interact with the type of video game that the person has watched or type of video that the person has watched. Factorial designs, just like previously one-way designs, also begin with the creation of initial equivalence among the participants across different conditions, and these designs help the researchers draw conclusions about the causal effects of all the independent variables that are involved in the design. So, let us take a simple factorial design to begin with, and maybe we can have more as we go forward. The simplest factorial design that you can have other than the one-way design, which is a separate experiment, is a two-way design. So, you add just one more independent variable, now you have a two-way design. Let us take it with the the current example that we have. So, our one-way experiment demonstrated that the children who have viewed violent cartoons subsequently did play more aggressively than those who had viewed non-violent cartoons. Now, let us say as a researcher we are interested in testing whether this relationship between viewing of violent versus non-violent cartoons will hold up in all situations, or will just be limited to a specific kind of situation. Okay. Say for example, you are interested in this child who was frustrated when he came to the experiment. You want to test whether this violent video watching will add to the effects of frustration or it will take away from the effects of frustration. What is going to happen? And so, you are now interested in the prior mood state, whether the child is frustrated or not, and the watching of the violent video game. So, you have two independent variables in play. So, the researchers can very simply, if they are interested in such a setup, they can very easily accomplish such a test by using a two-way factorial design having two factors to manipulate. The first factor is the same as in the first experiment. So, type of video watched, violent versus non-violent, and the second factor can be the prior state of the participant, frustrated versus non-frustrated. So, you have a 2x2 design. When you have a 2x2 design, you have 4 conditions. Okay. So, you have to take care of the fact that the participants are treated to each of the 4 conditions. We will talk about that very shortly. So, all of the children in this experiment, what will happen is all of the children are allowed to play with some relatively uninteresting toys in a play session before they are taken to view the cartoons. However, for we are seeing how do we implement this kind of a design. Okay. So, now you want to induce frustration in some way. So, what will you do? You will basically have all of the children, you take them to a playroom and they are allowed to play with relatively uninteresting, boring, run of the mill toys. Now, half of these children in the frustrated condition, what you do is the experimenter places some really fun, really exciting toys, but disallows these children to play with those toys. So, that causes a build-up of frustration. For the other half, these exciting toys are not even shown. So, they do not know that these toys exist and they will not be frustrated, they will play with whatever they have. Okay. After this has been done, they will be taken to watch the type of cartoons, violent or non-violent, and after that has been done, their aggression scores will be measured. So, this is basically the thing. Obviously, you start with the creation of initial equivalence. Now, you have, remember I said 2x2, 4 conditions. What are the 4 conditions? Look at it. Prior state frustrated, made them watch violent video games. Prior state frustrated, made them watch non-violent video games. Similarly, prior state non-frustrated, make them watch violent video games. Prior state non-frustrated, make them watch non-violent video games. So, you have 4 conditions as a result, 2x2, 4. You can see each level of the independent variable 1 occurs with each level of the independent variable 2. That is why you have 4 conditions. The dependent variable measurement will go on as it was going on earlier as well. So, you add, after you have created these 4 conditions, you again measure the aggression scores when the children are in the playroom. So, in these kinds of factorial designs, the conditions are arranged in such a manner such that each level of each independent variable occurs with each level of the other independent variable. This is known as the crossing of factors. I just demonstrated. The conditions obviously need to be equated before the manipulations occur. So, that is what you saw, the creation of initial equivalence at this side, and this is again typically achieved via random assignment of participants to one of the conditions, as we have been talking about. Now, the hypothesis in a factorial design experiment have to make very specific predictions about the pattern of means or pattern of measurement that is expected to be observed on your dependent measure, your aggression scores. Here, for example, the researcher predicts that the effect of viewing violent cartoons would be reversed for the frustrated children. Okay. The assumption is, let us say the intuitive assumption is, because for these children the act of watching the violent cartoons will automatically act as a catharsis or act as a way of releasing their frustration, and thus eventually it will reduce their subsequent aggressive behavior. Okay. So, when they are frustrated and they watch a violent cartoon, they sort of aggression gets a release, and now when they watch when they go to play, they will be less aggressive. On the other hand, when the non-aggressive children, non-frustrated children will watch the violent cartoon, their aggression will build up, and that you will see in the overall dependent variable measurement. So, let us word out this hypothesis. Sanger does it. For non-frustrated children, those who view the violent cartoons will behave more aggressively than those who view the non-violent cartoons. However, for the frustrated children, those who view the violent cartoons will behave less aggressively than those who view the non-violent cartoons. So, you can see there is an interaction that has been hypothesized, that has been proposed. Now, when you have this, when you have 2 variables, then you want to look at the main effects of both of the variables. Okay. In one-way designs, you look at the main effect of one variable, and it basically is a difference of means. It tells you, yes, the experimental manipulation worked or did not work. You can see here on the top, we have basically summarized our predictions. So, we are basically saying, in the frustrated condition, people who are who have watched non-violent videos basically will be watch the non-violent videos will be more aggressive than those who have watched the violent videos. In the non-frustrated condition, people who have watched the violent videos will be more aggressive than those who have watched the non-violent videos. This is the prediction, and this is, let us say, we have done this experiment, let us say some data has come up. Now, let us look at the data and see whether our hypothesis have sort of worked or not worked. Okay. You can see here there are basically condition means. So, you can see at the bottom there are these means for the violent condition versus the non-violent condition, and in the sides here, in the right side, you can see there is the means of the frustrated condition as well as the non-frustrated condition. Okay. So, these means show the aggression score for all. So, what did we really measure? What are these means showing? These means are showing the dependent variable measure that we have, which is the aggression score. Now, when the means are combined across the levels of another factor in this way, they are said to collapse across or basically control for a given factor. Now, when you have made this summation, made this mean across frustrated and non-frustrated variable for the violent condition, you are basically saying across both frustrated and non-frustrated condition, the mean for the violent condition is this. Across frustrated and non-frustrated condition, the mean for the violent condition is this. Similarly, across the violent and non-violent condition, the mean for the frustrated condition is this. Across the violent and non-violent condition, the mean for non-frustrated condition is this. So, basically what we are seeing is these are referred to as marginal means. Okay. They tell you about the effect of one variable across the other variable. Okay. Now, difference on the dependent measure across the levels of any given factor collapsing across other factors is called the main effect. So, the difference between these two means will be referred to as the main effect. Okay. So, we will do some statistics later, but let us say we in this experiment the difference between two marginal means these ones appears to be statistically significant. The children who viewed the violent cartoons actually behaved more aggressively than children who did not view violent cartoons. So, you can see here the mean is 4.5 versus 2.71. We will do the ANOVA later and we will show you that 4.5 here is statistically significant as compared to 2.71. Similarly, if you look at the frustrated non-frustrated condition, you can see here people in the frustrated condition were less aggressive overall as compared to people in the non-frustrated condition, but this difference did not come out to be statistically significant. Now, in factorial designs, not only there are main effects, there are also interaction effects. Say for example, how does a frustrated child, prior frustrated child react to seeing violent video games compared to non-violent video games? How does a non-frustrated child react to seeing violent video games versus non-violent video games? So, you have to basically compare the effect of each independent variable across the effect of other independent variable in the two conditions. Okay. So, the two main effects that we have seen in the current experiment, they provide the researcher with all the information that would have been available if you do two one-way experiments. You do one with frustration, change it less frustration, no frustration, or less frustration, high frustration, something like that. In another experiment, as we had done earlier, we saw seeing violent video game or seeing a violent cartoon versus non-violent cartoon. The benefit of doing a factorial design experiment is basically that now you can actually see the interaction between these two conditions. Okay. So, the two main effects will obviously, as I said, will test the influence of each of the independent variables, but in factorial designs we measure the interaction as well. What is an interaction? An interaction is a pattern of means that occurs in a factorial design when the influence of one independent variable on the dependent variable is different for the different levels. Okay. So, when watching violent video game affects the frustrated and non-frustrated child differently. On the other hand, when the effect of, say for example, frustration, I mean, you can word it differently in the same way. It's a 2x2 balanced design. You can basically say the effect of frustration on watching violent, non-violent video game sort of effects in there. Now, when we are looking at these simple effects, when we are basically looking at our hypothesis, the effect of one factor over the level of another factor is called a simple effect. There are main effects that are inferred through the marginal means here. When you are comparing the marginal means, and there are simple effects when you are comparing across different factors. So, if you compare 2.68 with 5.62 or 3.25 with 2.17, we will talk about this very shortly now. Now, the observed means in the four conditions in our experiment actually show that there is indeed an interaction and the between the type of cartoons watched and the factor of prior state. So, frustration or non-frustration. Let us zoom in a little bit. For the children who had not been frustrated, look at this one. For the children who had not been frustrated, basically you can see that they showed more aggression when they viewed violent cartoons as opposed to when they viewed non-violent cartoons. You can see 5.62 is being compared to 2.17. So, this is non-frustrated condition, both of these are non-frustrated. They, when they watch violent cartoons, show more aggression, and these guys, when they see non-violent cartoons, show less aggression. Okay. Now, this reverses for the children who have been frustrated prior to the experiment. Here you can see for the frustrated children, those who had viewed violent cartoons behaved less aggressively as compared to those who had viewed non-violent cartoons. So, you can see here it is 2.68 versus 3.25. Children who are watching non-violent cartoons in the frustrated condition are showing more aggression. Now, obviously, as I said, we will compare, we will carry out ANOVA. You basically look at the main effects of, you look at the main effects here, this is the ANOVA table, you look at the main effects of the two factors, cartoon viewed prior state, you also look at the interaction. So, these two are your dependent variables, and the dependent variable is, by the way, aggressive play. These two are your independent variables. Now, you can see here each of these have their own f values, they have their own degree of freedom, they have significance. So, you can see here very quickly, cartoon viewed is showing a significant effect, prior state is not showing a significant effect, but the interaction is significant. You can visualize this also in terms of these bar charts. You can see in the non-frustrated condition, people who were watching in a non-frustrated condition, people who are watching violent video games are showing more aggression as compared to people who are watching non-violent video games. And this effect reverses when you are looking at frustrated condition. People who are watching non-violent video games are more aggressive than people who are watching violent video games. So, this is basically what has happened. All right. Now, so in the current experiment, the main effect of cartoon viewed is significant, whereas the main effect of prior state is not. The interaction is also found significant. Here now, having done this analysis, it is also possible to compute, say for example, the effect sizes of each of the main effects and the interactions, which will basically tell you how big or how strong is the relationship between the levels of the dependent and the independent variable. Now, let us move on, let us try and study interactions. What kind of, because there are two variables, you can study interactions, you can see how are the two variables interacting with each other. Let us try that. As there are many conditions in a factorial design experiment, it might be beneficial to visualize the relationships between the variables using line charts. You can see here, these are the points which basically are means of violent versus violent condition. So, this is violent condition, frustrated versus non-frustrated, this is non-violent condition, frustrated versus non-frustrated, and you have basically joined them. So, one has become solid line, which is the frustrated condition, one has become the dashed line, which is the non-frustrated condition. Towards the 0 level, it is on the x axis, one side towards the left is the violent condition, the other side is the non-violent condition. Now, these lines here are basically telling us what kind of interactions are being observed. Okay. So, let us look at this. We know that there is a possibility, there is a main effect we have seen of watching violent video games. There is the main effect of prior state is not significant, and in some cases we see that there seems to be an interaction here, and in some cases not. So, we will go out and we will basically measure each or we will try and interpret these interactions in a way. Now, in the figures we can see that some of the many possible, there are obviously different interactions possible. We see how this is happening. A main effect of the cartoon variable is cartoon is present when the average height. So, you can see here when the average height of these 2 points is higher than the average height of these 2 points, when in the violent condition the score on aggression is higher as compared to in the non-violent condition. It is here also, it is here also, here it is not there. Here also it is sort of it is a main effect of frustration, but not of that. So, you can see in conditions where the mean height of the points in the violent condition are higher than the mean height of the points in the non-violent condition, we can infer that there is a main effect of the cartoon variable, what kind of cartoon these kids have watched. A main effect of the prior state variable is present when the average height of the line, the overall solid line versus the dashed line is greater than the average height of the non-frustrated line. So, here you can see, for example, in A there is a main effect of actually there is not a effect of frustration in that sense. If it were greater or higher, if or less than, then you would see that there is that effect. So, an interaction is present when the two lines are not parallel. When they are intersecting or not parallel with each other, it basically tells us that there is a simple effect of watching cartoons is different in the frustration condition and as compared to the non-frustrated condition. Now, we will go on and basically infer each of these plots. So, look at this. In figure 11.5a, there is only a main effect of the cartoon variable, but there is no interaction, the lines are parallel to each other. As a result, we can see that the proposed research hypothesis in our current experiment is proven to be incorrect. The children actually showed more aggression irrespective of the frustration or non-frustration condition. In 11.5b here, a main effect of prior state is only observed, because there is you know, a lot of difference. A main effect of prior state is only observed, showing that the frustrated children were more aggressive than the non-frustrated children. All right. So, that is what I was saying in A and B and C, you will see that there is a main effect of frustration available. In 11.5c, there are both main effects. There is the main effect of violence condition as well as the main effect of the frustration condition. Now, let us look at the other three. There are you know, where there are main effects as well as interaction effects. So, we can see in 11.5d, this one there is basically an interaction, because the lines are not parallel to each other and they will intersect at some point. If you look closely, you find that the interaction is not exactly as the research hypothesis that we started with predicts. Only part of this research hypothesis seems to be confirmed. Okay. What is it that we are finding? Is basically what we are finding is that the viewing of violent cartoons did increase aggression for the children in the non-frustrated condition. You can see that the means are different in the non-frustrated condition in this dashed line, but they are not affecting the aggression levels of the frustrated children. So, there is a main effect, there is, I mean, we talked about the main effects, there is an interaction here, but the interaction is partially affecting only people who are in the non-frustrated condition, but not really having an effect on the participants who are in the frustrated condition. So, here you can see that there is a main effect of the prior state variable, that is also significant. The solid line is higher than the dashed line. Okay. Now, pattern with main effects and interaction. So, we are going to talk about these two figures, E and F. In E, you see that the, you know, it shows basically the pattern that was originally predicted by our research hypothesis. In this case, we see that, you know, there is a crossover interaction. There is the effect of the simple effect in one level of the second variable is actually opposite. It is not just different, but it is opposite from the simple effect of the other level. So, effect of watching violent video games is opposite to the effect of watching, is opposite to the effect of prior state, frustration or not frustration. Okay. This is, by the way, termed as a crossover interaction. But in F, if you see the slightly the actual pattern is observed, let us see what is there. Here the research hypothesis is supported because the predicted crossover interaction is observed, but there is also an unanticipated main effect of the cartoon factor, that is the mean in the violent cartoon condition. The mean in the violent cartoon condition here is you know, slightly higher than the mean in the non-violent cartoon condition. So, when you collapse across these two versus these two, you basically find that there is a main effect of the cartoon factor as well. Okay. So, I hope you know, you are able to visualize and sort of make sense of how these interactions occur. All right. So, I will stop here. We will continue our discussion with factorial designs in the next lecture. Thank you.